Snowflake model related to the product Snowflake? No, I think they just picked it because it was a cute name. No, they are not related. The Snowflake platform is a cloud native data warehouse and it has a variety of data modeling approaches. You could implement a Snowflake schema in Snowflake, but it's not specifically for snowflaking or anything. I think they just were like, it's a fun name. People will know what a snowflake is. I don't know. They're special. They think they're special. Yeah, I don't know. Michelle has joined us, our interviewee. So I don't know, Michelle, if you have a take on that, if you've ever used Snowflake before.
Hello, everyone. Can see me? You
Hello.
can hear me?
Yes.
So, good afternoon. Thank you for inviting me. No,
Yes.
I don't have a specific experience with Snowflake product, but I agree with you that it's not necessarily linked to the Snowflake data modeling for dimensional databases.
Solid. Glad I got that one right. Okay. So, yeah, thank you so much for joining us. We are going to ask you a couple of questions about data modeling. But before we jump into that, do you want to give the audience like a quick introduction, talk about your background in data modeling, where your lived experience sits within this knowledge area?
Well, as you may have heard, I'm French Canadian, so English is my second language. And as a Canadian, I have to say sorry a couple of times, right? It's
Yes.
part of their reputation. So sorry if I make any mistakes. So I have more than 40 years of experience in IT, different roles I played over the time, but mostly was involved with operational application, operational software and databases. And I started data modeling very early in my career. And I did that up until last fall, where I decided to retire from the consulting side of my business and just continue teaching at the university some classes on different topic related to data management. I have my CDMP master level that I did in 2019 when DAMA rebooted the CDMP program. This is kind of the currently that's the second version of CDMP. So I did my 3 exams at EDW in Boston in 2019. So in the same
Wow.
week, I did the 3 exams.
A
Rough.
week.
I don't recommend it for everyone, but I did pass at a master level, so I was pretty proud of it. And
Wow.
then a couple of years later, I happened to be involved in the board of director for DAMA as the VP Professional Development. So I was overseeing at that time both the DMBuck Evolution and the CDMP program. So
Amazing, amazing background. So I'm
thank
sure
you.
now that you're retired, you're just like sitting around with your feet up, like totally relaxed.
Yeah, I decided to do video training and for the university and other group, and I will hopefully attend other conferences in the near future. We'll see.
Awesome.
Try to keep busy anyway.
Yes, sounds like a lot of fun. And what's the best way if people want to find your courses or learn more about you? What would be the best
Oh,
way for them?
LinkedIn will be a
Uh,
good way to find me. And the video I'm putting on right now, I put a first learning plan on dataversity that you may have heard of, kind of a computation to data strategy.
True.
Short.
We're
But
in collaboration to increase the awareness of the data management profession. So we're all friends here.
yeah, good, perfect. So I did a first learning plan called Understanding Data, and it has a course on the data introduction overview if you want, and another one on metadata, one on data modeling actually, and
Mm,
one on reference master and reference data.
amazing.
And I started a second learning plan would be more on managing activities such as data governance and data quality.
Wonderful. Wow, that sounds awesome. I'll have to go check that out. All right. We are going to focus specifically on data modeling today. Maybe we'll have to have you back at some point to talk about your experience in these other areas too.
Yeah, it'll be my pleasure.
Oh, awesome. So, given your background in relational data modeling, how do you decide when the relational scheme is appropriate?
For me, based on my background, my experience, if it's for a transactional system, transactional application, you will have to convince me not to use a relational database.
Mm,
Because relational database, one, you have to understand it's a technology that is proven. It's been there for 30, 40 years, 50 years almost. And it was designed and thought to be a robust system to reduce data anomalies when you create and update data, and it can embed business rules within the database itself that the programmer, yes, they can still add validation in the front end, but ultimately, if someone forgets some validation, the database will catch it and will prevent errors in the system. And nowadays, database, the RDBMS, the Relational Database Management System application, whether you pay for Oracle, Microsoft, or you go with a open license ones such as Postgres or whatever, they are pretty good from a performance point of view. They can store like huge amount of data, not as big data, but huge amount of data with good performance if it's done correctly, if it's done well. And the Noel solution, they are resolving some problems, but if they're not that problem that you have to resolve, stay with relational. One of the issues I've seen on the last few years is that there's a lot of databases system that will pop up and disappear a couple of years later on. They will not necessarily survive. And when you decided to use that technology and this vendor disappear and it's no longer supported, then you're in the wrong place. So using a proven technology, unless it's really not solving your problem, should be the main consideration.
Got it. So relational data modeling is like tried and true for transactional data stores.
Right.
And NoSQL kind of can address some specific edge cases, but they're just
Correct.
newer and essentially more unproven.
Correct. And I was there when you presented the different models that are explained in the DM book.
Okay.
Object dimensional is for all app data warehouses. That's a given. That's where you can use a dimensional modeling. But you can implement a dimensional modeling within an RDBMS, a relational database system. Object oriented, to tell you the truth, I don't see that anymore.
Right.
It's not the object-oriented programming is not that frequent anymore. The developer are now using other type of languages. Fact-based, I agree with you, it's more conceptual, but it's being used for ontologies that are very frequent for system to know that synonyms and things like that. This is based on ontologies. So you know that a chair is something similar to a bench or something similar to a sofa, for example. So this is based on ontologies, often based on using fact-based modeling. The timeline is often used for IoTs, Internet of Things, where
Mhm.
you receive sensor data on a regular interval. While using a time-based database, it's relevant in that case. NoSQL driven by big data where you have so much volume, so much entry, the velocity that you need different technology of relational database. And there's a trade-off. The trade-off is that the database will not validate your data, right? So someone else has to do it for you. It's either the programming or you say, I don't care if data is wrong. So that's the trade-off with NoSQL often.
Like the schemaless structure lacks
Right.
that inherent validation.
Absolutely. That's right.
Yeah. Okay, great. I'm definitely taking notes on what I can add to how we describe the different schemes. Cool. Let's see. How do you decide when to favor strict normalization versus intentional denormalization? Can you walk through a real world example project of when that trade-off came up?
Yeah. On my project, at some point in time, there were some trade-offs based on the strict rules of normalization. One of the first trade-off I often had to do is for security reason. We have to segregate some confidential data from the core table. For example, when I did the database for an HR system, an human resources system, we obviously for employees, you have the social insurance number. It's highly confidential. Birth date is highly confidential. So there's few information that you want to separate from the core data. So even though logically those attributes, those information should be in the same table as the employee table, it's easier to manage a security if you put them in a different table and put higher security on that specific table. So that's one of the reasons. The other reason is if you think about the time variation, how that information will change over time. And if you need to keep the history of that information for any odd reasons, then you have to separate, denormalize that to be able to track the historical values of that information. I don't know in the state, but in Canada, I know that a social insurance number for a person can change over time. For example, if
Mm.
that person's identity was stolen, the government will issue a new signature. But you may want
Wow.
to keep the old one for searching the values or mapping other information. So in those cases, the information will not be normalized, even though that for 99.999% of the cases, that value will never change. The other reasons for performance issues. For example, if you need to track two phone numbers for an individual and no more than two, our business rule says it's one or two, no more than two phone numbers. If you go with the normalization rule, you're not allowed to duplicate to have repeating attributes in a table. You should put that in a separate table. If it's only two and always two, and it's really a business rules, then maybe it's easier to just put the two for number one and two in the same table and not have a different table that you have to join and search and things like that. So sometimes for performance issues, you will have to break down the normalization. Yeah, that's about it.
Okay. So Yeah, just applying like common sense in addition to
Hmm.
understanding normalization best practices.
Yep.
Awesome. All right. When you design enterprise-wide models, how do you balance stability, i.e., like your core concepts, with the need to rapidly incorporate new domains and attributes and use cases over time?
And that's a good question. I had that previous experience. Last project I worked on was for a university in Montreal. They were redoing the new system. They were replacing legacy systems with them. And one of the business requirement or something that I observed was often the government will need, okay, we need to track a new attribute on the students. How can we do that? Or we need to track a new attributes on the courses to be able to group them based on, for example, sustainability. They wanted to be able to quickly identify all the courses that was dealing with sustainability. And in the legacy system, that implies either adding new columns in the system and changing the program, the new user interface, and everything, or overloading the free text fields with some kind of pattern to say this is the information, and that's a very bad idea. So what I did in the new system is I added a table for key value pair. So
Mm.
I borrow one of the new SQL concept of key value and said, we can do that ourselves. So I have a table with all the potential attributes that could be added into the system. And we designed the UI in such a way that it was dynamically looking into this table to create this UI. So that tomorrow I needed to add a new attribute. I just go into my dictionary of keys, say, okay, this is a new attribute. This is the name, the description. Is it string, a number, a check flag? Is it based on the list of values? I just had to add a table with the list of values, and then the application will automatically use that. And nowadays, with the new RDBMS system for transactional, you can also use composite type that are not part of the normal form. You're not supposed to use composite type based on the number form, but you can have a column that will contain JSON or XML or arrays of values, and that will add flexibility into your system if you program in consequences with that. So that's another thing we did. At some point, we just said, okay, this is semi-structured information, so we'll just use a JSON format for that instead of a free text, but it will have some structure in it. We can query based on that, but still give some flexibility without having to reprogram the old application because we add a new attribute.
That's so cool. That's really great examples of how you've borrowed the techniques from these kind of newer schemes to
Mm-hmm.
then make the validated original schemes kind of work more effectively with new data. That's so cool. Awesome. Okay. My next question for Michelle is, can you describe a case where conceptual, logical, and physical models diverged? What did you do to realign them, and both in terms of the business needs and the technical constraints?
Yeah, I've seen that most often when I had to move legacy data into a new system, a new database. The legacy data back to the university, but I had other example. The divergence was enormous because they basically didn't have a conceptual model, or they had it at one point in time, but they didn't keep that up to date. So the way we resolved that is before doing any type of data modeling, physical data modeling, was to sit down with a business stakeholder and truly understand what their core entities were. Not talking with the developer of the legacy system. At some point in
Okay.
time, I
Yeah.
had to understand the current database, but I said, okay, I'm not even going to look at the current database. I want to make myself a nice idea of what is the actual business like. They had a notion that the university program is, for example, a back in administration. Okay, fine, that's a program. But then they have specialties. You can do a back end administration with a specialty in finance or marketing or HR and so on. And then the program will evolve over time. So they have to keep the version of each program, each iteration, because the program is a contract with the students. When the student is being admitted, this is the classes you have to take to get your diploma at the end. 2 years later, if they change one of the mandatory class on the first year of the program, they won't ask students that are 3 years in their program to redo the first year. So your contract is basically at the point you were admitted in the program. So we have to keep history of that. In the
Mhm.
legacy system, they merge all those concepts into just one program, and it was creating a lot of difficulties of how to aggregate or separate information, how to find all the students that are on back-end administration, whatever the version, whatever the specialty. And going with the user, the business people, we decided to break down the program into program, variation, and version and keep that as separate level of entities. And that totally changed the physical modeling afterward. I'm pretty convinced that it's really helpful because now people have a better understanding of what they're talking about.
Mm,
So it's really go back to the business, the stakeholder. And in that case, it was a brand new database. So it was really converting the old data into the new one. That was a challenge by itself. But typically, when you have a system and there's a divergence, it's because maybe the conceptual level was not done correctly or with the
mm.
right people before. So go
Yeah.
back to the business people and really understand your data.
Okay. Yes. Good. Great points on communication strategy and like who to talk to. Okay, we're gonna let you get us some water before we hit you with some audience questions, if that's okay.
Yeah.
Sean asks, please stress on why creating a data model is an absolute non-negotiable.
Oh, and data model is basically a communication tool.
Yeah.
So you need a data model because you need to communicate what the data represents, and it's complementary to your business term glossary and other metadata that you have to discuss your data. Now, the conceptual level of the data model will be basically a visual representation of your business term glossary. That's how I presented it. Then the logical is a stepping stone toward a specific type of solution. It could be relational or NoSQL or dimensional. And then the physical is the actual representation of your data. So a visual representation is something similar to, well, imagine if you're going to build a dog house, the thing just for a dog in your
Yeah. A
right?
doghouse.
A dog house is fairly simple to create. You
Mm,
just think about a few measurements and you go and cut your piece of wood and nail them together. That's it. It's very simple. But if you're going to build a home or an office building, you will not start digging and starting pulling the foundation unless you actually have a good idea of where you want to go. And this is the modeling. The architect will model the building. The engineer will have details for the physical aspect of the building. It's the
mhm.
same thing for the database. I've seen project where I was called to audit a development. A company was hired by the client to do a new version of their operational system. Obviously, I cannot name either of them because it was not a good project. And one of the issue was that the new database was built, put together by developer as they were working on different use cases. And they were basically stumped because when they tried to load the legacy data in this model that had like duplicate tables and they were not able to. They spent a couple of years developing the application and then they spent 2 years trying to convert the data and they were not successful yet. And this is when we've been called. And I said, I'm sorry, but your database has no model. Nobody created a data model,
Wow.
either logical, conceptual, or physical. Physical is relatively easy after the fact, but it's
Mm,
wrong. This was absolutely not normalized and confusion in the concept. They had a table called account and they had foreign keys called customer ID with no physical relationship. And we didn't know if it was pointing to the account or the client table. So it was a lot of errors that could have been prevented. Someone took the time to do a model with the overall solution and see that doesn't match or we're missing some referential integrity rule here. So for me, it's really important to do a data model. And even if you go with a schema-less modeling, like a document-based like MongoDB,
mhm.
Mongo will not force you to have a schema before loading information in it. But how are you going to explain what's in it? How are you going to
Right.
tell the people, the data scientists, how to use that data after the fact? If everybody put anything in it, and then you have like there was a developer there was very good. It was very good, but it was how do you say dyslexic, mixed characters.
Sure.
So when you have a tool that does not enforce data on the entry, and like MongoDB, they were using Mongo, that programmer made error on the tag and nobody noticed it. And then they were trying to find the information, and the tag was sometimes not written correctly, and nobody find it. So that could be a problem. But this is why you need at least a data model, which can be used as a contract that this is what is expected to receive, even though it's not enforced in the database itself.
Yeah. Really great. Hitting it on multiple points. Loved that. So hopefully, Sean, we're getting a thumbs up. So hopefully that was really helpful to you in terms of emphasizing why it's crucial. Awesome. Okay, so next question is, how do you see modeling evolving with AI?
Ah, AI. Well, I think that AI will be useful to data modeler. For example, to make a nice diagram for a physical database that have hundreds of tables, it may become very complex. And so how to put the things there so it's easier It's not just say beautiful, but it's easier to read to understand. AI can most likely help you do that because a regular case tool would just put all the table over the place and draw lines and it's all spaghetti. So
Mhm.
I guess AI will be able to do that. This is the problem with AI. For example, not a transactional system that may be easier, but for a dimensional system, a data warehouse where you aggregate data from left and center, you have to get a coherent semantic content. You have to make sure that when you receive something called a client from system A and a client from system B, they are actually representing the same entity, the same
Mhm.
concept, right?
Yeah.
And so you can put them together and aggregate that information. AI cannot help you much right now with that because it's really about what does that business understand of that concept? What does marketing understand of what a client is? What is sales and operation understand what a client is? And that is still a human discussion to have in a work group and hash down what it means. So AI will be helpful, but I don't have much experience. As I said, one of the reasons I retired is because I didn't want to learn all those new stuff.
Darn
But
it. You're just washing your hands and leaving it for us
right.
to figure it
That's
out.
it. So I will let you young guys figure it out.
I hate that that's like the reality right now. We all have to figure out this massive paradigm shift. But yeah, I agree with what you're saying. Like with the AI implementation, there is that component of, okay, you have to validate, and you're saying the entire project is like validating essentially. And so you really can't use AI for that. There's no shortcut. You have to understand what data is going into these
Yeah,
models.
I can see AI helping when you do data quality project to do
Hmm.
data profiling and find
Yeah.
relationship into existing databases, but that's after the fact. It can help you find relationship or patterns if you want, but not for data modeling itself. And I think it's still human thinking about what you want to do and why you want to do it like that. It can help you maybe validate that your data model is correctly normalized. That maybe it will help you.
Okay, good. All right. I'm gonna keep going. We just had a whole bunch of questions. Awesome. Kenny asks, can you explain the practical applications of UML modeling?
UML modeling is really associated to object-oriented programming because you will create a UML model based on classes, which has attributes, either private or public attributes, and methods, which is something that will be programmed in the application, not necessarily put into the database. The problem with when we started to do object-oriented programming is that for example, you have a purchase order for a client or sales order, and then you have items, and items will be shown as a collection within the core object. Relational databases has separate tables, and there was a challenge to move data from one view to the other view, and they created object-oriented databases, which don't exist anymore. I know that was back in the 90s, so that was
Mm,
like 30 years ago. They created those databases to try to reduce the problem of moving data from an object model in memory in the computer to a physical relationship database model on disk. And this is why UML was useful. Now, UML itself is more than just data modeling. UML, you can model your processes, you can model your use case, you can model the whole application and not just the data. When you do a class diagram, you use one of the version of one of the deliverable of the UML, which is the description of your data in a static form. The other deliverable I still use in UML is what we call the state diagram to show the evolution of a specific entity within your transaction. And that is really helpful to identify all the state. For example, for a student admission at the university, there's different state, and that will reflect the values for the list of reference data for the state value. And you make sure that you don't forget anything and you understand there's an overlap and the transactions are good. So these are the two diagrams related to data modeling that we can use from UML. But as I said, the notion of a class nowadays, when they build a new application, web-based application using JavaScript, they don't typically don't do classes anymore. They don't. They use different type of programming for the application.
fair. Yeah. If we have any object-oriented programmers in the house, speak now or forever hold your peace. I thought they were dead, but my partner's a software engineer and he just went to a Java conference and he was like, oh
Oh
no,
no,
like
it's
it's
being used, but it's for specific needs. The language itself is object oriented, but the implementation, the logic will not be strictly object oriented. It's still be a mix of procedural in it.
fair
Be
enough.
more
But
scalable. That one of the problem with having a server that treats everything as a big object model is the scalability of it. At some point in time, it was becoming too huge, and they decided to use different approach.
okay. So you think we'll get a different list of schemes potentially with the DMBOK v3?
We'll see.
Yeah,
We'll see.
we shall see. Okay, last question, and then we'll have to wrap up. Speed round, do you prefer to enforce data quality rules using the data modeling or using the application front end from a performance point of view?
From a performance point of view, if I have to choose one or the other, we'll choose a database because that's the last thing, right?
Yeah.
So we'll use the database because eventually you may have other path that will go to your database to update the information, create new data, and you want the rules to be there. From a user point of view, you are not on a website. You enter all the information and then you click on go and then goes to the server, goes to the database, not good, go back. It's not as user friendly. So from a user perspective, we typically replicate most of the validation in the front end as well, or in the server
Mm,
in the between, right? Some of the validation may be more complex and really should not happen. For example, it may be not worth doing that work in the front end as well as the back end of the
hmm
database. So you can just keep that in the database. Some other rules are very rare, but you want to make sure that you can monitor them. So what I did at the project at the university is I wrote a series of script that validate a lot of things that could go wrong, but I could not put directly as quality rule on the insert because that would have been too complex and too long. And we run that script like every week once to find out if something like fall between a crack or something that fall like that. So you really have to look into what is easy to implement in the RDBMS and the database itself, like mandatory field, that's easy. Referential integrity, lookup table, that's easy. Having an end date later than the start date in a table for a project, these things are easy to put in. But if you have, for example, back to my program where each version of a program has a start date and an ending date, and obviously we don't want to have gap between those two because well, we
mm.
need to have one version that's active and we don't want overlap either, have two versions active at the same time. And that was too complex to validate at the insert. So we rely on the front end application to do some validation for that. And then this is an example of the program I was running on the side after the fact once a week that said, do I have programs version that are overlapping or with a gap in between?
Very good. Awesome. Okay, that's all we have time for, unfortunately. This was great. Really appreciate the thought out, nuanced answers based on your abundant experience. Thank you so much to our guest, Michel. This was awesome.
Pleasure. Have a good weekend, everyone, and good luck in your exam.
Yes, good luck to everybody studying.